A step-by-step guide to building your own computer, from part selection to assembly and cost-saving tips. Introduction: Building your own computer can be a rewarding and cost-effective way to get the perfect system tailored to your needs. In this comprehensive guide, we'll take you through the process, starting from creating a bill of materials to assembling the components and optimizing your budget. Whether you're a tech enthusiast or a first-time builder, this project-based article will provide you with the knowledge and tips to embark on your DIY computer building journey. When embarking on a DIY computer build, creating a well-thought-out bill of materials is a crucial first step. It not only helps you set budget limits but also enables you to build a system that meets your specific performance requirements within that budget range. In this section, we'll delve into the importance of building a bill of materials and how it empowers you to achieve a cost-effective, customized computer build without compromising performance. Defining your budget. Before diving into component selection, it's essential to establish a clear budget for your DIY computer build. This will serve as a guiding factor throughout the process, ensuring that you stay within your financial limits. Setting a budget upfront helps you prioritize components and make informed decisions while avoiding overspending or unnecessary upgrades. Identifying performance requirements. Next, consider your specific performance needs and expectations. Are you building a gaming rig, a multimedia powerhouse, or a workstation for resource-intensive tasks? By clearly defining your performance requirements, you can allocate your budget to components that will provide the most significant impact in those areas. Researching and comparing components. With your budget and performance goals in mind, conduct thorough research on various hardware components, such as motherboards, RAM, storage devices, and CUS. Compare their specifications, performance benchmarks, and price-to-performance ratios. Look for reviews and recommendations from reputable sources and consider the compatibility of the components you shortlist. Balancing performance and cost. Building a bill of materials allows you to strike a balance between performance and cost. Depending on your budget, you can allocate more funds to critical components that directly impact performance, such as the CPU and CUE, while compromising on less crucial components, like aesthetic enhancements or peripherals. This flexibility helps you optimize your build to achieve the desired performance within your budget limitations. Future-proofing and upgradability. Building a flexible system is an additional advantage of creating a bill of materials. By selecting compatible components and planning for future upgrades, you can extend the lifespan and adaptability of your computer build. Consider factors like the availability of upgrade slots, expansion ports, and compatibility with future technologies to ensure your system remains viable for years to come. Utilizing online resources and example builds. To assist in the process of creating a bill of materials, leverage online resources, forums, and community-driven websites that offer pre-configured example builds within various budget ranges. These resources provide valuable insights and recommendations, helping you fine-tune your own bill of materials while considering real-world scenarios and user experiences. Building a bill of materials for your DIY computer build is a fundamental step that empowers you to create a cost-effective system without compromising performance. By setting a budget, identifying performance requirements, conducting research, and balancing component choices, you can achieve a customized computer build that meets your needs within your budget limitations. The flexibility of a well-planned bill of materials ensures future upgradability and allows you to stay within your financial boundaries while maximizing performance. Take advantage of our online resources and example builds to refine your bill of materials and embark on an exciting journey of building your dream computer. Here are some tips for selecting a processor and a comparison between Intel and AMD, along with reasons why someone might choose one architecture over the other. Determine performance needs. Consider your specific performance requirements. If you need a high-performance CPU for tasks like gaming, video editing, or 3D rendering, you may opt for a more powerful processor. For everyday tasks like web browsing and office productivity, a mid-range processor will suffice. Compare specifications. When comparing processors, pay attention to the following specifications. Clock speed. Higher clock speeds generally indicate faster performance. Core count. More cores allow for better multitasking and improved performance in multi-threaded applications. Cache. A larger cache enhances performance by providing faster access to frequently used data. TDP, thermal design power. TDP indicates the power consumption and heat dissipation of a processor. Intel versus AMD. Intel processors have long been considered a standard in the CPU market. They often excel in single-threaded performance, making them well-suited for tasks that rely on strong individual core performance, such as gaming. Intel processors also tend to have integrated graphics, which can be beneficial for systems without a dedicated graphics card. AMD processors, particularly those in the Ryzen series, offer strong multi-threaded performance at competitive prices. They are often preferred for tasks that benefit from parallel processing, such as video editing, content creation, and streaming. AMD processors typically offer more cores and threads for the price, making them attractive for multi-threaded workloads. Price-to-performance ratio. Consider the price-to-performance ratio when comparing Intel and AMD processors. AMD processors often offer a better value proposition, providing comparable performance to Intel counterparts at a lower price point. However, Intel processors may have an edge in specific use cases that heavily rely on single-threaded performance. Compatibility and future-proofing. Ensure that the chosen processor is compatible with the selected motherboard. Consider the availability of upgrade options and future CPU compatibility when selecting a specific processor and motherboard combination. Both Intel and AMD release new CPU generations regularly, so future upgrade options should be taken into account. Budget considerations. Evaluate your budget and determine how much you are willing to spend on a processor. AMD processors generally offer more affordability in the mid-range and lower-end segments, while Intel processors often dominate the higher-end performance market. Ultimately, the choice between Intel and AMD processors depends on your specific needs, performance requirements, budget, and preference for multi-threaded or single-threaded performance. It's recommended to research benchmarks, reviews, and comparisons of specific processor models to make an informed decision based on your unique use case. Here are some key factors to consider when choosing a motherboard for your DIY computer build. Compatibility with the processor. The most crucial aspect is ensuring that the motherboard is compatible with your chosen processor. Check the motherboard socket type and chipset to ensure it supports the specific generation and model of your CPU.